So thank you for joining this morning. We have HashiCorp software engineer Nick Kabatov here. He's part of the Vault core team. Nick will go over some of the new features of Vault 1.1, including demo secret caching with Vault Agent, new authentication methods, and other new features of Vault 1.1. And then, as I mentioned, we will spend the last 15 minutes of the webinar dedicated to a live Q&A. Again, this webinar is recorded and will be sent to all of you after post-processing, which usually occurs 1 or 2 days after. In the meantime, as I mentioned, feel free to put questions in the questions box, and we will answer them at the Q&A. And with that, I'm going to pass it off to Nick.
Thank you, Lynn. Let me start my screen sharing. Not Slack. That looks right. So, welcome everyone. My name is Nick Kabatov. As Lynn said, I'm on the Vault core team. I'm going to be showing you the new Vault 1.1 features, which include secret caching, OIDC authentication, and transit auto-unseal. A few words about these different features before I get into the meat of it. OpenID Connect, or OIDC, is a way to use a third party to do authentication via the web browser. And we have many integrations that have already been tested, including Azure Active Directory and Google. But even if you don't see an integration listed for the provider you want to use, you should give it a shot anyway, because it'll probably work once you get the right settings. Secret caching is a new feature in Vault Agent that lets it run as a caching proxy. You can use this to reduce load on Vault, but you can also use it to simplify your applications by letting them delegate lease renewal to the agent. And Transit Auto-Unseal is like Cloud KMS or HSM Auto-Unseal, but where you use another Vault cluster to auto-unseal your new Vault cluster without having to manually enter keys at startup. I wanted to mention that the demos I'm going to be showing you are all available online at this repo, the Vault 1.1 webinar. And on top of that, each of the things I'm going to be showing you are spelled out in even more detail in these tutorials, which are really great and show you how to do all of the steps using the command line or the user interface or the HTTP API with curl. Let's start with OIDC-based authentication. There is a notion in Vault of identity. So we have this concept of an entity, which is some outside user or a system, and we can cross-reference that entity from multiple authentication sources. So John Smith could log in using their GitHub credentials or connecting from one of these two different LDAP systems, and we would still know that underneath it all, they are John Smith. And this provides a really powerful and flexible way of managing policies, because you can attach these policies to the entity itself, and regardless of what mechanism they use to authenticate, they will have these policies attached to the token they get as a result. There are also notions of groups of entities and group aliases, but it starts getting a little bit complex in the abstract, and I'd rather introduce you to those in the context of OIDC so that will make it more concrete and easy to understand. So I'm going to refer to OpenID Connect as OIDC from now on. And it's a big, complex topic. There are some great talks out there that you could listen to if you want a better understanding of it. Really don't have enough time to go into much detail, so I'm just going to introduce a couple of concepts that we're going to refer to later in configuration and in the demo. An ID token is a JOT token that you get back from the OIDC provider upon successful authentication. And that JOT token contains claims, which are just name value pairs. And we use those claims to build up the entity and to do the login process, basically, and figure out what this user should have access to. So the conversation between OIDC and Vault goes something like this. When the user tries to authenticate using OIDC and Vault, Vault will open a browser and point it at the OIDC provider, and it will arrange to have a redirect URL that points back to itself. When the user authenticates successfully, they get sent back by their browser to that redirect URL, meaning back to Vault, and that redirection includes the ID token that came from the OIDC provider. Vault will then parse the claims in that ID token and log the user in. This last bullet is what we already had with the JOT authentication method from older versions of Vault. So it's the bits preceding this that are new in Vault 1.1. Let's go and try our first demo. So to run these demos, you're going to need a few dependencies installed, and there's a separate README for OIDC because it's big and complicated. It's not too bad, actually, but compared to the others, it's a little bit more involved. So you can use many different OIDC providers. I decided to use Auth0 for this demo because their whole business is authentication and authorization, so I figured they would make it easy. They would provide lots of tutorials and hand-holding, which was good because I didn't know anything about this before I started preparing this talk. So I'm just going to log in. I've already created an account. You can create a free account. It doesn't take long. I've wiped out all the stuff I think I have from my previous preparation attempts. The only thing I left behind is under Connections Social. I've left Google and GitHub enabled as integrations. So when you start, and this is all spelled out in this README. So we've done step 0 and step 1. Now in step 2, we're going to application, default app, which is pre-created for you, and settings. So here we are. We're going to click on settings for the default app. And the first thing the README wants you to do for step 2 is to create a file named .env and put in it these three values, the domain, client ID, and client secret, which are these first three settings after the name in the application settings. So I have already done this step prior to the meeting. So here's my .env file. All those things are already filled out for me. Now, while we're still in the settings menu, we need to go and copy and paste this into the allowed callback URLs field right here. So these are the callback URL for the Vault UI, and if you wanted to use Vault login at the command line, this is the one you'd need. You don't need to use both unless you want to provide both of those options. So we hit Save Changes. Yeah, it does give some feedback. And now we're going to run this demo script. Well, maybe let's look at it quickly before we run it, just to explain what we're doing. So this is going to start a dev instance of Vault. It's going to set up a little minimal policy. We'll explain what that's for in a bit. It enables OIDC as an authentication method, and it configures it to point it at Auth0. Again, this is based on what's in the .env file that we populated a moment ago. And it's going to configure a default role of demo. Then we're going to configure the demo role, and we're going to set up the redirect URIs, put in another value from the env file, specify that we want the min policy to apply to any tokens that are created using this role, And this user claim is a required field. It refers to a claim inside the JOT token that uniquely identifies the user. It's almost always going to be sub. I haven't yet seen a provider for which it isn't. It's a kind of a standard JOT token for OIDC, or claim, sorry, for OIDC. So let's go ahead and run this. Okay, so that seemed to work. Let us connect to Vault. Oops. That's no good. Okay, let me just give it one more try just in case. I don't see any reason why it would work this time, but I did it so many times in practice runs where it worked just great. So I'm very frustrated and confused. Oops. Huh. Okay, well that's better, I think. At least the UI is opening. Okay, I have no idea what went wrong the first time, but at least now we can continue with the first demo. Sorry for the diversion. So we're choosing OIDC as the method to log in as. We're going to sign in with auth0. I'm going to use GitHub, and I have to grant it permission. All right, so now we're logged in. We don't have access to much of anything. Like normally you would see secrets here, but I can't interface to secrets because we have a very limited policy that was set up for us. The only thing we're allowed to do really is we granted access to the identity path so we can look at our entity. This entity, since we have a fresh vault, was created by our login. And we can see that it was created just now. And if we look at the alias, we see that it's a GitHub alias coming from OIDC, and we don't have any groups. So let's quickly go and do the steps required to enable groups. So you could do this many ways, but the way that I found that was easiest with auth0 was to go and edit your user and add to your app metadata this field roles with a value of admin. Then we're going to create a rule with this as the body. So go to rules, create rule, use the empty rule template. I'm going to paste this as the body, and we're going to give it a name, roles. And what this is going to do is in the generated ID token in this unique field, and you have to make sure it's unique, so you should be using your own domain. This was fine for a demo. And then we're going to store into that key the value of the app metadata roles that we just populated. And if you don't have one, it's going to use the empty list, and you should do that because Vault will be very unhappy if that isn't a list. So now, having set that up, we can go back and run part 2 of the demo. And part 2 of the demo is going to create this more generous ADM policy that can do other things like access secrets. It's going to extend the demo role that we created originally to add a groups claim. And this is the same value that you saw we were populating in that rule into the ID token. Then we're going to create a group that's attached to the ADM policy, and we're going to save its ID. Then we're going to create a group alias that's attached to that group that is bound to the OIDC authentication method, and that has the name admin. So what's going to happen is that when you log in, Vault is going to see the group claim in the ID token coming from our rule. It's going to iterate over the list of values it finds in that list of groups. And if it finds any that match a group alias, it will add the user to that group if they're not already a member. And as a result, any token that they get when they log in will have those groups' policies included. So if we now run the part 2 of this demo, it goes and modifies the demo role and creates that group, which is what we can see here. And so now if I sign out and sign back in, because it's not going to retroactively add that policy and group. Now I'm signed in again, and now you can see that I actually have access to secret, so I could go and create a secret of whatever. And if we look at the entity, we now see that this entity, which is the same one as before, our GitHub entity, now has a group attached, and that's the name of the group we created, and we can see it's got the admin alias, and it has the ADM policy, which is how we're able to access the secrets. Let's talk about the agent cache. So the agent already had a feature called auto-auth, and the way this worked is you configure the agent to tell it how to authenticate to Vault using some method like AWS or app role. And the agent logs into Vault when it starts up and gets a token, and it renews the token when it needs to, and when the token's max TTL is reached, it re-authenticates. Anytime that the agent gets a token, it writes that token to file syncs, which are paths on disk that you configure in the agent's config. And there are various options to protect the token so that you're not just writing plain text to disk. Now, to enable the agent cache, you add a cache block to your agent configuration, and you configure one or more listeners for the agent. And you modify your application so that the Vault AGRA is pointing to the agent instead of to Vault. Then, when the agent receives requests from your application, it may proxy those requests to Vault, sending along the request and its headers and returning any response it receives. Or it may return immediately without speaking to Vault at all. It might decide that it already has the secret cached and it can give you the information directly without involving Vault. Or it might be a lease that you're trying to renew that it knows doesn't need to be renewed yet, and so it's just going to return without doing anything, saying success. The interaction of these two features is pretty straightforward. If you include a token in your request, then that token will be used, and there won't be any auto-auth involved. If you don't provide a token in your request, but you have put into your agent's cache block, use auto-auth token equals true, then the agent will insert a token into the request for you. And if you don't do either of these things, then your request is just going to fail and be unauthenticated. The scope of the cache is tokens and dynamic secrets. In other words, things with leases. This excludes, for example, KV secrets. And it's a bit different from most caches you might be familiar with in that it doesn't evict things in order to make room for new things. It keeps everything until the lease has been revoked or when it expires. The exception is that there is a new API that the agent provides that can be used to explicitly revoke things. And you would use that if, for example, something has been revoked without going through agent. So agent has stale information in its cache and it doesn't realize it. The agent also takes care of auto-renewing any leases that it has cached, but there are some caveats with that. So the first bit of fine print is that it will only auto-renew leases if they were created using tokens managed by the agent. So if you got your own token by some other method and you provided it in your request and you got a lease going through agent but with your own token, agent will not auto-renew that. It's assuming that you want to have control. And there are some gotchas associated with this, some sort of surprising behavior to some people. There is a standard Vault behavior that's always been this way, which is when a token expires, any secrets that were created with that token also get revoked. And so when the agent's auto-auth token expires, any secrets that were created will be revoked as well. And this may be surprising because your application is delegated responsibility for the secret to the agent. So you want to make sure that when you set up AutoAuth, you probably want to have a periodic token or set a very high max TTL in order to avoid surprises like this. And the next warning is kind of a consequence of the first. The agent is stateless and doesn't write anything to disk. And when it exits, it's not going to know about the AutoAuth token that was used in a previous invocation. So eventually that AutoAuth token is going to expire, and so will any leases created with it. So these problems can be dealt with, but you have to take them into account when you're designing your architecture. Are there any new security concerns with Agent? Well, let's see. Like Vault, it keeps secrets in memory, so there is the possibility that if someone gets access to the host that's running Agent and the user it's running under, then they can extract them from memory. Now, unlike Vault, you're going to probably be running Agent in many more places, including possibly closer to the edge, maybe in a sidecar along with your application. So at first glance, it looks like this is riskier, but remember that Agent isn't going to have any secrets that your application doesn't. It's only going to be exposed to secrets because applications ask for them. So in principle, this probably won't make any difference to your security risk, but everyone's needs are different and you're going to have to evaluate them for yourself. Now we have another demo, and hopefully this one goes smoother. So for this demo, we have a little script that is just basically going to run Docker Compose. And in our Docker Compose, we have Prometheus to collect metrics, Node Exporter to report, oh, let me make this font bigger, sorry. Node Exporter to report on the metrics of the host, Grafana to visualize the metrics, Vault, because we're using Vault, and a bad application. And this bad application is using the Vault image just so we have access to the Vault tool. It's going to point at the Vault container, and we're going to specify just the shell as an entry point. And so we're going to set up a very limited policy where all that you can do is renew your own token. We're going to wait until Vault comes up, and when it does, we're going to write that policy. Then we're going to get a token bound to that policy, and we're going to use that as the token that we're going to run this bad application as. And the bad application is very simple. All it does is connect to Vault, and then in a very busy loop, try and renew its token. It's sleeping for 5 milliseconds a loop, so up to 200 times a second it will try and do that. And it's also exposing a listener and publishing a metric so we can see from its perspective how often this is running. So let's go ahead and run that. Oops. And now we get a 10 of output on standard out. And if we go to localhost 3000, we should now be able to log in and see a dashboard. So here we've got these 5 panels. One of them is showing host CPU, so how busy the machine is. Another is showing disk activity. And this is showing the metric that we saw in the bad application earlier. So it's running that loop 100 times a second. And I can hear my fan spinning up. These are metrics coming out of Vault. I'm not sure why it says 200 update auth tokens per second, even though the app is only invoking it 100 times. There's some internal implementation detail I must be missing, but it doesn't really matter for our purposes. And these are effectively writes. So it's doing a bunch of disk activity. And this doesn't look so bad, right? It's very, very small. But remember that I have a very fast disk. I'm not running anything else that uses the disk. And there's only one application doing this for one lease. And if you were using something like console, a write is much more expensive than a write to my laptop's SSD. So this isn't exactly representative. Okay, so it doesn't look so great, right? We're seeing maybe 15 or 20% CPU and some disk activity, some writes that we would rather not see. So what if instead of running it that way, we go and we replace that bad app with this bad app? And so it's still the same application, still running in the Vault container, but we're not actually asking for a token. We're just going to rely on the agent, which we're connecting to on port 8007. The agent is talking to the real Vault, and it waits for Vault to come up, and then it spawns the agent. I'm not going to show you the details because I don't really have time. And then it just sleeps and lets the agent run in the background and handle requests. So if we run that now, now we see that the application is running a bit faster. It's doing 150 loops per second instead of 100. Vault is seeing basically no activity, no writes. CPU is smaller. It's still non-zero because the application's still busy looping, but Vault doesn't have to do anything, and agent can very quickly respond with a no-op saying, you don't need to renew yet, and we're not seeing any writes to disk anymore. So that was all I wanted to show you for the agent cache. The next item is the transit auto-unseal provider. And in here, let's first recap how unseal works in the various pre-existing modes. With manual unseal, you split the key that's needed to decrypt the Vault encryption key into many pieces, and you give each piece to one person. And you need a plurality of those people to supply their keys at startup in order to unseal Vault so it can start servicing requests. Cloud-based auto-unseal was made available in open source Vault in 1.0. And here what happens is that the encryption key for the Vault master key is stored in a third-party cloud provider's KMS. And with Enterprise, you also have the option of using an HSM. Now we're adding still another option where transit behaves like the cloud KMS or the HSM. So this is a nice option if you want to run on-prem and you don't want to shell out a ton of money for an HSM. They are very expensive. So here we have a little diagram showing the old way with manual Shamir unseal and the new way where we have this Vault 1 that has a transit engine enabled, and its transit key is used by Vault 2 to decrypt the master key on startup. Setting this up is straightforward. On your primary Vault cluster, you need to enable transit and then create a transit key. We're going to call ours unseal key. Then you need a policy that's going to restrict access to that key. So this policy only allows encryption and decryption using that key. And we're going to call this policy use unseal key. Finally, you need to, oh, sorry, I skipped a step. Now you need to create a token that's bound to that policy. This is not how you would do it in prod because there's no provision for how the token is going to be renewed. But for our demo, this is fine. Finally, in your new Vault, you need to, in its configuration, create a seal stanza of type transit, and you need to reference the Vault address of your primary Vault and the transit key that you created in the previous steps. You also need to give the mount point, which defaults to transit if you don't specify something explicitly. Now you start and you init your new cluster and you provide in its environment Vault token with the value of the token we just created in the previous step. So long as you provide that environment setting and the token is still valid, your new vault can be restarted and it will unseal itself without you having to intervene. Let us check out that demo. So this script is a bit more involved and I don't want to go through it in too much detail, but the gist of it is we start the primary and get a root token, and that primary is going to listen on 8200. We enable transit, we create the key, we create the use unseal key policy, then we create the token attached to that policy and we store it in this environment variable. Now we're going to start the secondary and we're going to run init on it. And we're going to save its root token inside this environment variable. That means that these commands will be using that vault token. So we're going to be running as root on the secondary because we set vault agra to 8202. So now here on the secondary, we're going to create a KV value. This is just so we can validate that it's coming up and unsealing itself correctly. So we're now going to kill it and start it again, still providing the transit, the token that allows access to transit on the primary. And we're going to try to read back the key that we stored a moment ago to make sure that everything came up correctly. Sorry about that. All right, this time I do know what's going on. This is the previous, yeah, this is the, I believe, the previous vault's, previous vault demo interfering with this one. Phew, all right. So here we can see from the output, it started the primary, it configured it with Shamir seal and unsealed it, enabled transit, created the key, created the policy, brought up secondary on 8202, enabled KV, wrote a value, killed secondary, started secondary, and then read the value back. Let's see whether anyone has any suggestions for what was wrong with the original demo. Don't see anything. That was it. Thank you for your attention, and let's move on to questions.
Thanks, Nick. So the first question is, will the OIDC features support conditional access? That is, different rights based on how someone or something is authenticated. Nick, did you hear that question?
Yeah, I'm just digesting it.
Oh, okay. No problem.
So, yes, if I understand correctly, so you can have many of these roles and you can specify different policies for the roles based on the attached group claims. So if I understood what you're asking, you can certainly have different privileges depending upon who's connecting. Actually, could you repeat the question because I maybe didn't fully understand it?
Sure. The question was, will the OIDC feature support conditional access? That is, if different rights based on how someone or something is authenticated.
Yeah, so I guess the confusion is the how someone or something is authenticated was a little bit ambiguous to me, but yeah, in principle, absolutely.
And just as a follow-up, someone asked, presumably the ID token is signed?
Yes.
Great. So the next question is, what is the need for sync when we enable cache?
What is the need for what?
What is the need for a sync when we enable cache?
Okay, so if you are using the cache, you can actually omit the file syncs if you want. It's not strictly required any longer. It has an in-memory sync that it will use to populate the requests that are missing tokens. So it's a good question. You do not need syncs unless you want them.
Okay. The next question is, any plans to bring caching to the KV store?
I don't know.
Well, for any questions that we don't answer here, we'll make sure to follow up afterwards. The next question is, can we enable transit auto-unseal without having to reissue the current shards?
I'm not sure. There are some migration facilities for converting between one seal system and another, but I'm not very familiar with them. Maybe someone else on the call has some idea?
Just to repeat that question, it was, can we enable transit auto-unseal without having to reissue the current shards?
Yeah, I think you can, but I hesitate to say yes because I haven't actually played with any of the seal migrations.
I'm hearing seal migration will switch the unseal keys to recovery keys without changing the shards.
Thanks, Mike.
Sure.
There are a couple of other members of the Vault team on the call to help answer questions. The next question is it possible to unseal one Vault cluster with a cluster already unsealed from a transit backend?
Sorry, can you repeat that, please?
The question was, is it possible to unseal one Vault cluster with a cluster already unsealed from the transit backend?
I don't think I understand the question.
Let's see. We'll come back to that one. Next question is, can you please show the Vault config for primary and secondary Vault for transit unseal?
Yeah, sorry, I meant to do that and I kind of skipped over it. So for the primary, it's nothing special, just the bare minimum really. For the secondary, it looks just like what we had in the slide really. Well, you know, there's the basic minimum and then the transit stanza is like what we had in the slide.
Okay, for Vault agent caching, what is the need for sync file when cache is enabled?
I think we answered that one already. You don't need a sync file if you are using caching. It's only if you want it.
Okay, next question is, can Vault agent work with a Kubernetes auth backend?
I haven't tried it, but I see no reason why not.
Next is, can Vault cache KV secrets in case Vault becomes unavailable or a network partition of some kind happened?
Not at this time.
This is more of a feature request. Any plans to support watching for changes to secrets while the Vault agent is caching, similar to Console's ability to watch for changes via the API?
I don't know what is planned in that area.
Let's see. Are there plans of releasing a HashiCorp Helm chart for Vault, or even better, an operator in the near future?
I know there's some work ongoing regarding Kubernetes integration, but I don't know the specifics.
Next question is, can we use transit key to implement disaster recovery between on-prem and off-prem clusters?
I'm not sure why you're thinking of disaster recovery in this context. I think the short answer is no, but maybe you need to expand on what you have in mind.
The next question is, does Vault agent keep the cache in TMPFS in memory FS?
No, it's just stored in the application's main memory.
Got it. So right now, okay, here's another question. Is it possible to cross-unseal two Vault clusters?
I don't know what cross-unsealing means, but if you mean to have cluster A unseal cluster B and cluster B unseal cluster A, no, I don't think that would work.
So the next question is, there's a lot of questions about sync. Is there a way to encrypt sync or write to RAM disk?
Yeah, there's a few different mechanisms available to protect sync files. So you can use wrapping such that you need to access it via a cubbyhole. You can also enable Diffie-Hellman encryption, wherein you write the public key to a file that the agent consumes, and then it will encrypt the token on disk using that public key such that only you who have the private key can read it.
The next question is it possible to set the maximum cache size?
Not at this time.
Okay. That seems to be all the questions we have so far, unless anyone wants to last minute plug in some questions for Nick here. Oh, here comes another one. Can transit auto-unseal help with unsealing a secondary cluster member within a single Vault cluster?
Help with unsealing a secondary cluster member within a single Vault cluster. I'm not sure what you mean by a secondary cluster member. Do you mean like a standby? In a single Vault cluster, there's only one storage, one thing that can be unsealed. So I don't think that question really makes sense. But maybe I'm just not understanding what you're getting at.
Let's see if Mark, who asked that question, wants to clarify. Any more questions for folks on the line? There's one more question. How do we automate secondary Vault unsealing via primary in transit mode? For the demo purposes, the token was created to be used on the secondary.
Right. So there are a few different ways you could do it, but one way would be to use the agent. Originally, I was going to include a demo about that, but I ran into time limits. But you could have the agent be writing a token to a file sync that then is being used in your startup script in order to provide the token that that your secondary Vault cluster needs.
Great. We have time for just one more question. Is there a way to unseal the on-prem cluster from the off-prem cluster in the case of disaster?
So I'm not really sure what you mean by the on-prem cluster and the off-prem cluster. You can already, even in Vault 1.0, you could have like a cloud KMS a cloud KMS system do the hold on to the key and use that as your unseal mechanism. So that would be an, oh, well, okay, you could also run another Vault system in the cloud off-prem and use its transit key as an alternative.
The person
That
wants to
way,
clarify that it's a hybrid cluster.
I'm sorry, I don't know what a hybrid cluster means in this context.
Sorry, I'm just reading through the comments. How does Vault Agent know when to renew a lease? So tokens have a lease in 24 hours and max TTL of 10 days. What's the trigger window?
So there's some cleverness in there. It certainly doesn't wait until right when the TTL is going to expire. It's somewhere in between, like 50% of the expiry and the actual expiry, and I think there's some randomness as well to avoid a thundering herd style problem. I don't remember the specifics as to it, exactly when it chooses or what the algorithm is. But as to the first part of your question, how does it know when to renew the lease? It got back the response from Vault that you issued and that it's proxying. And so it parsed the result and it actually knows the TTLs of everything that it's storing in its cache.
Awesome. Going back to that on-prem cluster and off-prem cluster, hybrid cluster question, they wanted to clarify, so a few nodes are on the cloud and some are on on-prem data centers.
Okay, so if this is a single cluster, so these are all, well, one node is active and the others are standbys, they're still all going to share the same underlying storage. So it doesn't really make a difference in a way whether there's one or many and whether some are on-prem and some are off-prem. There's still the same concerns, which is if the storage is on your local system on-prem, then you are going to have to find some way to unseal it. And again, I don't really see how this relates to disaster recovery unless you mean that you want to use transit and you want to use this second cluster to unseal your primary one, and you want to have a backup or a failsafe in case your primary Vault cluster whose transit you're depending upon becomes unavailable. And I don't have a quick answer off the top of my head. I think this is one we're going to have to think about and get back to you.
All right. That's all the time we have for questions. I know there were a couple trickling in, but we're trying to answer them in the send out in 1 or 2 days. So first, I want to thank everyone who submitted questions and to Nick for doing the presentation and fielding the answers. I hope everyone enjoyed today's webinar and has a better understanding of Vault 1.1's features. If you want more webinars, we do have a couple coming up. You can visit hashicorp.com/events. And finally, as I mentioned, this was recorded, so we are going to send out a recording and slides and answer the remaining Q&A. I know there are a couple comments about links to the GitHub repo as well, so we'll try and include those. So keep an eye out for that, and have a great day.